So let us revise briefly what we were doing in the last video. So last time we were studying about the atom. Now you are already familiar with matter, so you know that matter is made up of elements and compounds. It's anything that occupies space, that has got some mass. But what are these elements and compounds further made up of? Well, they're made up of molecules, and molecules are made up of atoms. Atoms are the fundamental building blocks of matter. Now, there was a time until which it was thought that even the atoms are the indivisible particles, the ultimate fundamental particle, but we now know that there are particles which are even smaller than the atom. If we break an atom, if we divide an atom, we even get certain subatomic particles. এবারে অ্যাটমের আইডিয়াটা, এই অ্যাটম নামটা এটা কোথা থেকে এসেছে? The atom term was first, it's actually a Greek term. It was first used by this natural philosopher known as Democritus. Democritus belonged to Greece, and Democritus coined this word atomos, from which we use the present day variation of atom. And then in 1808, that is a lot of years later, Democritus, when we talk about Democritus, this is actually something like the 3rd century before Christ, so it's a lot of long time ago. In 1808, John Dalton proposed his atomic theory. অ্যাটমিক থিওরি পস্টুলেটগুলো এগুলো আমরা লাস্ট ক্লাসে করেছিলাম, যে সব এলিমেন্টই আলটিমেটলি অ্যাটম দিয়ে তৈরি, যারা টাইনি হয়, খুব ইনডিভিজিবল হয়। তারপরে এই অ্যাটমদেরকে ক্রিয়েশনও করা যায় না, ডিস্ট্রয় করা যায় না, যে জাস্ট লাইক কনজারভেশন অফ মাস। আর এই অ্যাটমগুলো যখন কোনো কেমিক্যাল রিয়াকশানে involved থাকে, when they take part in a chemical reaction, they always combine in simple whole number ratios in fixed small whole number ratios. যদি আমরা NaCl এর এক্সাম্পল নিই, একটা সোডিয়ামের সাথে একটা ক্লোরিন অ্যাটমই অ্যাটাচ হয়। আর অ্যাটম, একটা এলিমেন্টের সব অ্যাটম সবসময় আইডেন্টিক্যাল হয়, বাট ডিফারেন্ট এলিমেন্টসের অ্যাটমসটা ডিফারেন্ট হয়। ক্লোরিনের সব অ্যাটম আইডেন্টিক্যাল, বাট ক্লোরিনের অ্যাটমের সাথে ম্যাগনেসিয়ামের অ্যাটমের কিন্তু একটা ডিফারেন্স থাকবে। আর ফাইনালি যখন এই কেমিক্যাল রিয়াকশনসে এই অ্যাটমসগুলো ইনভলভড থাকে, when they take part in the chemical reaction, it's not that new atoms are created or old atoms are destroyed, it's simply that the atoms rearrange themselves. In the year 1879, it was William Crookes who first performed certain experiments with the discharge gas tube. The discharge gas tube consisted of these 2 electrodes. You saw the diagram in the last class. And in between the electrodes there is a near vacuum which is created by a vacuum pump. Then a gas is induced into the discharge tube. When a high potential difference or a high voltage is applied between the anode and the cathode, it is generally observed that there is a glow in a direction opposite to that of the cathode. These rays were called the cathode rays. These cathode rays, what were they consisted of? Well, they are consisted of electrons. Initially they were named corpuscles by J.J. Thomson, but later another scientist named Fitzgerald named these corpuscles as the electrons. And these electrons, or these cathode rays, are found to be deviated by magnetic field as well as by electric field. They are attracted towards the positive plate in an electric field. J.J. Thomson tried to measure that what is the charge of the electron, what is the mass of the electron, but he could only calculate the charge to mass ratio. Individually the charge or mass could not be calculated by him, but now we know that electron has a charge of -1 coulomb, and it has a mass of 9.1 in 10 to the power minus 31 kilograms. It's almost negligible. It's 1 by 1840 times that of a hydrogen atom, so it's negligible mass. Using this same cathode ray tube, Goldstein, another scientist, discovered the protons. But what Goldstein did is that he used a perforated cathode, that is a cathode which contained a number of small holes on its surface. And surprisingly, he found that there was a glow not only in the direction opposite to the cathode but also in a direction opposite to the anode. That means there must be some rays or some particles which are produced by the anode. These were named by him as the canal rays, and they were found to be deflected by an electric field in the direction opposite to that of the cathode rays. So he came to the conclusion, Goldstone said, that protons or these positively charged particles make up the canal rays. After this electrons and protons were discovered, scientists started to think, well, their atomic model or the atomic structure is almost foolproof, because electrons have negative charge, protons have positive charge, and as a whole the atom is neutral, as it should be. And as a result of that, many scientists started proposing their atomic models. The first one of them was proposed by Sir J.J. Thomson. He proposed the model which came to be known as the plum pudding model. And what is the plum pudding model? According to the plum pudding model, it's as if the entire atom is a sphere of positive charge, and in this sphere of positive charge the electrons are randomly distributed. That is what the idea of Sir J.J. Thomson's plum pudding model was. But it was soon found that this model is not true. It has got a lot of fallacies, after which came Ernest Rutherford, and Rutherford performed the famous alpha scattering experiment. An alpha scattering experiment has got some serious implications. So first of all, what is this experiment? Ernest Rutherford performed this experiment in the year 1911. So in this experiment, the main aim for Rutherford was to know that inside the atom, where is the protons and electrons situated. As obtained by Sir J.J. Thomson and by Eugen Goldstone, it was already known that atoms do have protons and electrons, but nobody knew how these electrons and protons are arranged inside the atom. So for this, Rutherford performed this experiment. What he did was, he made alpha particles from an alpha particle source. By the way, alpha particles are actually helium nuclei. So helium as an atom contains 2 protons and 2 neutrons, and then there are 2 electrons moving around the nucleus. If you remove these 2 electrons, what remains is the nucleus. This nucleus of helium is an alpha particle. So Ernest Rutherford made alpha particles from alpha particle source fall on a thin gold foil. It is very thin. It's only about 40 microns. 1 micron is around 10 to the power minus 6 meters. So that is definitely very thin foil. So Ernest Rutherford made these alpha particles fall on such a thin gold foil, and surrounding the gold foil there was a semicircular screen that was coated with zinc sulfide, which has this property of producing fluorescence whenever any charged particles strike it. So this was the experimental setup. What was observed? It was found that most of the fluorescence happened in this region directly behind the gold foil, so which meant that most of the alpha particles passed straight through the gold foil. And it was also observed that some fluorescence happened at random regions in other portions of this circular screen. So that meant that some of the alpha particles were deflected quite sharply from their original path. Now this was the observation, but what is the conclusion and what is the reasoning behind this observation? The conclusion that Rutherford provided was that most of the alpha particles passed straight through the foil. So if these are the atoms of gold inside the foil, suppose these are the atoms of gold which are present inside the foil, then most of these alpha particles, they passed straight through the foil. They had almost no deflection at all. Some of the alpha particles were deflected at smaller angles. Say it collided like this, or one of them may have collided like this. So they suffered very small deflections. A few alpha particles suffered a large deflection, so much so that they almost returned back to their original source. Now this was the conclusion, but what was the reasoning, or what was the postulate that Rutherford gave after this experiment? Well, Rutherford said that based on this experimental result, that there must be a positively charged core called the nucleus inside the atom, and it is this nucleus which contains the protons. Remember, even neutrons were not discovered at that time, so they thought that nucleus only contains the protons, and almost all the mass of the atom is concentrated in this nucleus. The electrons, they do revolve around the nucleus, but they revolve very far away from the nucleus. There is a huge gap between the nucleus and these well-defined paths of the electrons. These well-defined paths of the electrons were given the name orbits, much like the orbits of the planets. As a result, this model of the Rutherford was also named as the planetary model or the orbital model of the atom. And finally, as it was already known that an atom is electrically neutral, the number of protons must be equal to the number of electrons. So if there are 10 protons, 10 positively charged particles in the atom, there must be 10 electrons or 10 negatively charged particles inside the atom. This was Rutherford's idea. After that came another scientist by the name of Niels Bohr, and Niels Bohr had another atomic model which he proposed in the year 1913. So what was the proposal of Niels Bohr? According to Niels Bohr, the electrons, they revolved around the nucleus in particular orbits. So Niels Bohr said that the electrons move around the nucleus in particular orbit. Well, this is nothing new because Rutherford had already said it, but he gave these orbits the name shells. And he even named the shells K shell, L shell, M shell, N shell, and so on. The innermost shell is K shell, outermost is N, and so on. And he said that each orbit is associated with the definite amount of energy. That is why these shells were also called as energy levels. The energy associated with this energy level, they increase as you go away from the nucleus. So if there is a nucleus here and there is a shell here and there's another shell here, suppose an electron is moving in this shell, this is a K shell, another electron is moving in this shell, this is the L shell. The electron moving in this shell, that is the L shell, will have a greater energy than that moving in the K shell. So the farther away from the nucleus you move, the greater will be the energy. It was after this that in the year 1932 James Chadwick discovered the neutron. Why or how did the neutron discovery come into being? Well, the charge was already balanced. Scientists knew that there are as many electrons as there are protons because the atom is electrically neutral. But when the mass of the atoms were calculated, it was found that the total mass of the atom was always greater than the sum total of individual masses of the protons and electrons. So there was some missing mass. There was something in the atom which was massive but which had no charge. And this led the scientists to the conclusion that there must be a particle inside the atom, like the neutron, which is neutral in charge. That is, it is neither positively charged nor negatively charged, but it has got a mass. And in 1932, James Chadwick discovered the neutron, for which he even won the Nobel Prize. The neutron carries no charge and it has a mass almost similar to that of the proton, 1.675 into 10 to the power minus 27 kg. Now I was saying this the other day that you already know that an atom can now be divided into proton, neutron and electrons. But if you go even further, deep inside you will find that even these proton, neutrons and electrons are made up of something called quarks. The quarks are at now the most fundamental particles we know of. Once upon a time, people or scientists used to think that atoms are the most fundamental. Then they came to think that proton, neutron and electrons are most fundamental. They cannot be divided any further. Now we know that, well, they can even be divided, and those after division, the fundamental particles thus obtained are these quarks. Now we have done these basic studies. Now what about the nucleus and the nuclear region? Well, if suppose this is the nucleus, what is present inside the nucleus? neutrons and protons. And what is moving around the nucleus in the shells? Well, those are the electrons. But there is something that I must say here, because it's not generally mentioned in any book, that the nucleus is incredibly small as compared to that of the whole size of the atom. The atom as a whole has got a radius of 10 to the power minus 10 meters, whereas the nucleus has a radius of around 10 to the power minus 15 meters. So the nucleus is 10 to the power 5 times smaller than the atom as a whole. That is how small the nucleus is, or how big the space is between the nucleus and the atoms. 10 to the power 5 means 1 followed by 5 zeros. So this many meters means something like 100 kilometers. That's how much, if you are trying to put it to scale, that's how much far apart these nucleus and electrons are. So if suppose you have a ball in your hand, a tennis ball. So if you have a tennis ball in your hand, and if that tennis ball is the nucleus, then the electrons are situated somewhere in Khorda or say in Damdam. That is how far the electrons are, just to put a scale to it. Now we define something as the atomic number and the mass number. So what is the atomic number? Atomic number is the total number of protons that is present inside a nucleus, and mass number is the total number of protons and neutrons present inside a nucleus. Therefore, to find out the number of neutrons is simply the mass number, subtract from it the atomic number. And since an atom is overall neutral, the total number of protons, that's P, is equal to the total number of electrons, which is ultimately equal to the atomic number Z. So the atomic number Z gives us the total number of electrons and the total number of protons, whereas the mass number helps us to know what is the total number of neutrons.